begin working on this problem that I gave to you because it synthesizes all of the information that we will need for our exam tomorrow. And why are you laughing?
I don't know.
Anyway, this is what your worksheet looks like. So first of all, you want to make sure we understand what the question is asking. Many times research actually shows that when students get questions wrong, many times they don't understand what the question is actually asking. So that's very frustrating to know information and not to be able to get it out in a way that you get credit for it. So what is an isotope? If this problem is all about isotopes, it would help us if we knew what that was. Jenny?
It has like the same atomic number but different number of neutrons.
Yes. So, and what was the analogy that I used? Did I use here about the identical twins?
They're way different.
Yes, they weigh different, like the Wetzels, one skinny, one fat. Well, they're not skinny and fat, but if one were skinnier than the other.
I was going to say, I thought they were both.
No, they're both skinny. So, isotope has same number of protons, but different neutrons. They behave the same. And how do scientists know that these even exist? You guys love this.
Carbon 14.
The cannon.
Yes, the little atomic cannon.
Hey.
They shot them out and they got the two different piles. Like if I threw a baseball and a bowling ball, I throw like a girl, I know. But which one would go further?
Baseball.
Because it's lighter. So they did that with a little atomic cannon. They shot the little atoms out and they found two piles. They recognized they behaved the same, but they had different masses, and we call them isotopes. So for this particular element, we don't know what it is, there's 4 of them. And they give us this thing called percent abundance. What the heck's that about?
How much they found.
Can you say it again, Brian?
How much they found.
How much they found. So what does this tell us? Are they all here in equal amounts?
No.
No.
What is the most common form?
2.
We're guessing our favorite number less than 5. What's the most common one?
2.
2. And how do we know that?
70.
This is the largest number. So that means if I took 100 of this atom, of this type of atom, 79 would be of this type. So the first question asks us to figure out the mass number. So that means I have to know what mass number is. Who can help us out there?
Neutrons and protons.
Do we agree with Jenny?
Yeah.
So this is neutrons plus protons. Now the next important question is, how the heck do I figure that out? Do I look at my neighbor's paper and hope they got it going on? Well, how do we find out protons?
By atomic number.
And where do I find that, Kevin?
Here are two.
Here at a table. So I could walk over there, but oh my goodness, there's 115 of them there.
Jesus.
How do I know which one we're talking about?
You don't.
So I can't do that right now. So what is another way I could figure out the mass number?
Could you round off the isotope?
Say that again, Brian?
Can you round off the isotope?
So let's think about what is this number telling me here? That if I took this particular isotope and put it on a scale or a balance, it would weigh 37.765. Now, does that make sense to us?
No.
No.
How come? What's weird about that?
Doesn't give us the units.
We don't know.
Oh, thank you for saying that. It does give us the units. AMUs from your vocab from Quizlet. Does anybody know what AMU means? Atomic mass unit. And what is that?
It's a unit of measure.
It is a unit of measure. What's it based on? Ooh, Jeopardy music. Look in your notes.
What was the question again?
What is atomic mass unit based on? Like I could have a unit called the Kevin. What do you weigh, Kevin?
190.
It would be based on 190 pounds. So I could say, you know, Jenny weighs half a Kevin. Somebody else weighs 2 Kevins. Something like that. So this is based on something.
Mass of atoms or molecules?
That's what it measures, but what's it based on? I think it says in your Quizlet vocab.
Protons and neutrons.
Yes, say it again.
C12.
Carbon 12, yay, bing, 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 correct answer over here in the corner. Carbon with 12. Now when it's written this way, what does 12 mean?
12 protons.
Does carbon have 12 protons?
No.
Ooh, this is going to be an interesting exam tomorrow. What does 12 mean? The mass number, yes. So this is telling us this form of carbon has 12 things in its nucleus. So how would I find the number of neutrons for this particular form of carbon? So, Allison just told me this is the mass number, which is what?
The
Neutrons and protons, right? So how would I find the neutrons?
Find the atomic number and then
Excellent. Say it again, Lindsay.
find the atomic number and then subtract.
And the atomic number I find,
There.
so for carbon I have two numbers to choose from, 6 or 12.011.
6.
What's this 12.011?
The
Mass.
The mass. So 6 is the proton, so if I take 12 and I minus 6, what do I get? And that represents
Neutrons.
the number of neutrons. All right, so sometimes we see atoms written this way. So let's come back to our problem here. So this particular isotope was experimentally determined to weigh 37.765. Isn't this kind of odd to have a decimal?
Yeah.
Because if I took, let's say, take this carbon-12 atom that we know has 6 protons and 6 neutrons in it, what else does it have in it? And where do those go?
Outside.
And I'm going to do the fried egg model. They're flying around here. If I could put this one element on a scale and weigh it, or balance, excuse me, what would it weigh?
some weird uneven number.
12. Talk to me more about why it weighs 12. Why don't I count these guys?
Because they weigh, like, they don't weigh enough to be counted. They're like 1/1000th or something like
Yeah,
that.
even tinier. It's 1/2000th of an electron, of a proton. So I would need 2,000 electrons to weigh one proton. So if this one atom weighs 12, how come this has got this gobbledygook on there?
This is like carbon 14, it's just average.
Well, remember, we don't know what this is. But why is it a decimal? Because again, if I use the atomic cannon and shot a pile full of this stuff out, and these are all sitting in one pile, there's a pile of them, they should only weigh 12, right? So it should be a whole number, correct? Because I can't have fractions of protons and neutrons. So what's that stuff? But if I'm averaging something that's always a whole number, I'm going to have a whole number, right?
Yeah.
So what do we think this is?
An average?
You guys know this. You know reasons why that decimal is there.
There's more of one than the other?
Well, remember, this is only one kind. So this is the pile that was shot out of the atomic cannon. So they're all the same. Now, if I'm measuring billions of atoms, do you think this might start to add up?
Yeah.
Could it?
Those are the electrons.
Yeah, so it could be the electrons. Another potential reason why that's a decimal is when you guys measure things, what kind of information do you get out? Like if I asked you to measure the length of Jenny's hair, did we all get the same number?
No.
How come?
It's an approximation.
They're not all the same length.
I didn't even think about that. That's a good answer, that hairs aren't all the same length. I was going more for there's always error in measurement, right? It's never completely 100% accurate to the nth degree. So two things going on here. We could have mass of electrons adding up. We could have experimental error. So how do I figure out the mass number? If I know this pile of atoms that shot out of the atomic cannon weighs 37.765 according to the balance, how do I figure out its mass number? Knowing the mass number has to be a whole number.
Round up.
I could round up. What's my other strategy? If we think this is all due to the electrons, what could I do? Get rid of it. Do we have a preference?
I'd take it out.
All right, Coyle said take it out. So our mass numbers then are going to be straightforward, right? This one's going to be what?
39.
39. This one's going to be
40,
40. And this one's going to be,
41,
and what are our units?
and
Atomic mass units, based on carbon-12. Why do you think scientists picked carbon-12? Why did they pick Kevin?
the most abundant.
Because there's
Is it-
a lot.
Yeah, it's common. It's not the most abundant element, Brian, but it is the most common. Well, how come? Or it is very common.
Carbon
Because
dioxide.
it bonds with so many.
It does bond with a lot of things, but what's carbon in?
Everything.
Soda.
It's in soda. It is in soda because it's in sugar. Well, isn't carbon what life is based on? Organic chemistry, the chemistry of life. What are you made of, largely?
Carbon.
Carbon, water by weight, but a lot of carbon in it. All right, so are we good with figuring out what mass number is? Isotopes.